Welcome to the video. Today we will uncover the critical missing number in many retirement planning tutorials, the assumed growth rate. We will use the time value of money, or TVM, to show how to project the future value of consistent contributions, regardless of account type. We will tie everything together with a practical framework and a realistic rate range so you can estimate your future wealth. First, let's map our journey. Here is the agenda for this session. First, we will establish why the time value of money matters. Next, we will break down the future value of an annuity formula. Then, we will confront the controversial growth rate dilemma and compare nominal to real returns. After that, we will give you a step-by-step method to pick your rate, run a worked example, and finish with quizzes, key takeaways, and a brief disclaimer. Let's begin. The time value of money states that $1 today is worth more than $1 tomorrow, because it can be invested and grow. In retirement planning, what truly drives outcomes is a combination of consistent contributions and the growth those contributions earn over time through compounding. Therefore, understanding how to project that growth is essential. Now let's break down the formula most relevant to long-term contributions. This is the future value of an ordinary annuity formula. The three inputs are payment P, which is your total annual contribution including any employer match, the expected return R, and the time horizon T in years. The formula assumes contributions are made at the end of each year, which is called an ordinary annuity. If you contribute at the beginning of each period, which is an annuity due, you multiply the ordinary annuity result by 1 plus R. As we move forward, keep in mind that the most sensitive input is R, the growth rate. This flowchart illustrates the process. Start by gathering T, P, and R. Then determine if contributions are made at the end or beginning of the year. Compute the future value using the annuity formula, and apply the start-of-year adjustment if needed. Finally, view the result as a range by testing conservative and optimistic real rates. This encourages scenario testing to understand sensitivity to the assumed rate. Many textbooks avoid stating a concrete rate because market returns vary widely. However, ignoring the rate undermines the entire projection. Over decades, small differences in the assumed growth rate can translate into large differences in outcomes due to compounding. Therefore, a practical approach is to use a realistic band of rates rather than a single number, and interpret results as a range rather than a precise forecast. Next, let's clarify nominal versus real returns so your projections reflect purchasing power. Nominal returns include inflation, and often average near 10% over very long horizons for broad stock indexes. Real returns, in contrast, subtract inflation, and therefore better reflect purchasing power. For retirement planning, real returns are typically more informative, because what matters is how much your savings can buy. As guidance, many professionals test real rates around 5 to 8% to form a realistic outcome range. Now that we have that distinction, let's define a step-by-step method to choose your rate. To choose your rate, begin by identifying how many years remain until retirement. Then compute your total annual contribution including any employer match. Next, set a conservative real rate at 5% and an optimistic real rate at 8%. Compute the future value at both rates, creating a realistic range. Conduct a sensitivity check by varying the rate by 1 to 2 percentage points. Finally, revisit these assumptions annually and update your inputs as your situation evolves. Now, let's ground this with a numeric table. This table uses the ordinary annuity formula for a 30-year horizon. At a 5% real rate, the annuity factor is approximately 66.4. At an 8% real rate, the factor is approximately 113.25. Multiplying those factors by the contribution levels yields the displayed future values. Notice how moving from 5% to 8% results in hundreds of thousands of dollars in difference over 3 decades. Next, we will reinforce that the account label is less important than contributions and compounding. The label of the account does not alter the future value math. Whether you contribute to a 401k, IRA, or taxable brokerage account, the future value of an annuity computation is the same. What differs are taxes, fees, and contribution rules. Be sure to include any mandatory employer match in your annual payment. Over the long run, consistent contributions and compounding growth have the biggest impact. Now, let's visualize the savings journey along your timeline. This timeline shows that each year you contribute payment P and your balance compounds at rate R. Over 30 years, these repeated actions build the future value. The diagram emphasizes that even small changes in R, the growth rate, have large effects on the final accumulation due to compounding. It also reminds that if contributions are made at the start of each year, you apply a 1 plus R multiplier to convert from an ordinary annuity to an annuity due. Quiz time. Which variable is most often missing in retirement projections, yet has the biggest impact over time? Option A is time, option B is payment, and option C is rate. You may pause the video now to think about the answer. We will discuss the answer in the next section of the video. The correct answer is rate. The growth rate is the key assumption that many materials omit, and it dramatically affects projections over long horizons. Second quiz. For realistic, inflation-adjusted planning, which pair of real rates is recommended to build a range? Option A is 2% and 4%, option B is 5% and 8%, and option C is 9% and 12%. You may pause the video now to consider your answer. We will discuss the answer in the next section of the video. The correct answer is 5% and 8%. Using both provides a realistic range for planning. Next, we will perform a worked example to consolidate the method. Here is a worked example. Suppose your horizon is 25 years and you contribute $12,000 annually at year-end. Using the ordinary annuity formula, the factor at 5% real is approximately 47.72, yielding about $573,000. At 8% real, the factor is roughly 73.13, yielding about $878,000. If you contribute at the beginning of each year, multiply the ordinary annuity result by 1 plus the rate. Therefore, the annuity due values are approximately $601,000 at 5% and $948,000 at 8%. This illustrates how a realistic range frames uncertainty while still guiding decisions. This mind map organizes the framework into inputs, methods, outputs, and risks. Inputs include time, payment including employer match, and the rate, distinguishing nominal from real. Methods include the ordinary annuity formula, the annuity due adjustment, and sensitivity testing. Outputs focus on conservative and optimistic future values to create a range. Risks remind us of market volatility, fees, taxes, changing contributions, and sequence of returns risk. These are the key points. The time value of money and consistent contributions drive outcomes. The future value of an annuity depends on payment, rate, and time, with the rate being the most sensitive and often omitted variable. Use real returns to reflect purchasing power, and test both 5% and 8%. Remember that account labels do not change the math, though taxes and fees matter. Revisit your assumptions annually and stress test the rates. In summary, model your savings using the future value of an annuity. Choose both a conservative and an optimistic real rate. Run scenarios to observe the spread, and update your plan annually. Now, before we close, please review the brief disclaimer. This content is educational and not financial advice. Markets are volatile and your results will vary. Fees, taxes, and contribution patterns can materially impact outcomes. Consult a qualified financial professional for advice tailored to your specific situation. Thank you for watching. If this video helped you clarify your retirement forecast, please like, share, and subscribe. We would love to hear in the comments what rate range you plan to test and how you will apply this framework to your own plan.